All right, let's jump right in. We're about to unpack a story that starts with a tiny imaginary demon from over 150 years ago. But believe it or not, it leads us straight to the cutting edge of quantum computing and the future of technology itself.
So could a tiny demon actually break one of the most fundamental laws of the universe? That's the wild question that the brilliant physicist James Clerk Maxwell threw out there way back in 1867. He imagined this little creature that could challenge a core rule of reality. And it wasn't just some idle thought. It took scientists a century to figure out the answer. And that answer, well, it changed everything.
Okay, first things first. Before we can really get into what this demon does, we've got to talk about the law it was supposedly breaking. What exactly was its alleged crime?
We're talking about the second law of thermodynamics. You could think of it as the universe's ultimate one-way street. It's the reason heat always flows from a hot thing to a cold thing, never the other way around. It's why a scrambled egg can't just unscramble itself. Basically, order always breaks down into disorder. Scientists have a word for this measure of disorder: entropy. It's the reason your room gets messy all by itself, but never, ever cleans itself up.
But what if you could cheat that law? That's what Maxwell wondered. His setup was pretty simple. Just picture a box, totally sealed, filled with gas molecules that are all just zipping around randomly. Everything's at the same temperature, the same pressure. It's in what physicists call equilibrium. It's perfectly boring, perfectly disordered, and nothing interesting should ever be able to happen.
Okay, so then he imagined putting a wall right down the middle of the box, splitting it into two chambers. And in that wall, there's a tiny little door. The key here is that this door is totally massless and frictionless. It costs zero energy to open or close it.
And here is where it gets really interesting and really tricky. He imagined a tiny little gatekeeper, a finite being as he called it, sitting right at that door. This little guy, which later got nicknamed the demon, is smart. It can see every single molecule coming its way and make a split-second decision.
So what does this demon do? Well, it could do a couple of things to cause trouble. First, it could act as a temperature demon. See, temperature is really just the average speed of molecules. So the demon could watch for fast, hot molecules and only let them pass into the right chamber while only letting the slow, cold ones pass to the left. Or it could be even simpler and act as a pressure demon, just letting molecules go from left to right, but never from right to left. A perfect one-way valve. And just think about what happens. One side of the box gets hot, the other gets cold. Or all the gas ends up on one side, creating high pressure. The demon has created order out of total chaos, and it didn't seem to do any work to make it happen. You could use that temperature or pressure difference to run an engine, forever. It's a perpetual motion machine, powered only by information. And that, according to physics, is a huge no-no. This simple thought experiment created a massive paradox that seriously bothered physicists for about 100 years. So the hunt was on. There had to be a hidden cost, right? The demon must be paying for this somehow. And the answer, funny enough, didn't come from the world of engines and pistons. It came from a totally different field that was just getting started: information science.
And this was a real team effort, stretched out over decades. You had Leo Szilard in 1929, who was the first to really link information and energy. Then, much later, Rolf Landauer discovered the key missing piece of the puzzle. And finally, in the 80s, Charles Bennett connected all the dots and solved the whole thing.
Landauer's big idea was a true game changer. He basically said, hey everyone, information isn't just some abstract idea. It's not just ones and zeros floating around in the ether. Information is physical. It has to be stored on something real, a brain cell, a hard drive, something. And because it's physical, it has to obey the laws of physics, including thermodynamics. And this is where we find the hidden cost. It's called Landauer's principle. What it says is that anytime you erase information in a way that's irreversible, like wiping a computer bit back to zero, where you can't tell if it was a 1 or a 0 before, you have to pay a price. And that price is a tiny puff of heat that gets released into the environment. Basically, forgetting things has a physical cost. You can't get rid of information for free.
So Charles Bennett took Landauer's idea and applied it directly to the demon. He realized the demon's process goes like this. 1, it sees a molecule. 2, it has to remember what it saw. It stores one bit of information in its memory, fast or slow. But here's the catch. Its memory isn't infinite. So 3, to be ready for the next molecule, it has to erase its memory. And 4, that's where it pays the cost. That little act of erasing that one bit of memory releases heat. And Bennett showed that the disorder created by that heat is at least as much as the order the demon created in the box. The books are balanced, the second law is saved.
So, paradox solved. That's a great story. But what's really wild is that this isn't just a story anymore. For the better part of 150 years, this was just a thought experiment. But now, with modern nanotechnology, scientists can actually build these little demons in the lab.
Now, to be clear, they're not trying to build free energy machines. The real goal is to test these ideas in the real world, to really poke at that fundamental connection between information and energy. And they're getting creative, building these things out of photons, particles of light, or tiny superconducting circuits, or even using a single atom trapped by lasers.
Let me give you a really cool example. A photonic demon uses light. Instead of a box of gas, it has two beams of light. A super-sensitive detector acts as the demon, watching for tiny random fluctuations in brightness. When it sees one beam get a little brighter, it quickly uses that information to open a gate and shuffle some energy over to charge up a capacitor. It is literally converting information about random noise into stored electrical energy. How cool is that?
So what this all proves is that Maxwell's demon is way more than just some old philosophical puzzle. By finally solving it, we've stumbled upon a completely new rulebook for engineering at the smallest possible scales.
The big lesson from the demon is that all that random noise in the universe, it isn't just an enemy to be avoided. It's a resource you can tap into if you're smart enough. And this idea is inspiring all sorts of real-world tech. We're talking about tiny information-powered refrigerators for microchips, devices that can literally harvest useful energy from waste heat, and maybe most importantly, it's giving us the foundational ideas for how to control and protect fragile quantum computers.
And check this out for a modern update. Researchers have actually built a digital demon to help prepare quantum bits, or qubits. A qubit has to be in a very specific low-energy state to work right. So this demon just checks. It measures the qubit's energy, and if it's not cold enough, it just resets and tries again. It's a simple feedback loop based on one bit of information, good or bad, and it made the process 20 times more reliable. That is a huge deal if you're trying to build a quantum computer that actually works.
And it's evolving even further. The demon is going from a thought experiment to an actual algorithm. Scientists are now training AI to be the demon. Using machine learning, the AI figures out the absolute best strategy to watch a quantum system and intervene to cool it down or protect it from errors. Maxwell's intelligent being is literally becoming a real-world, smart algorithm.
So in the end, what started as this clever little puzzle to try and break a law of physics did something way more important. It revealed this deep, fundamental connection between energy, disorder, and the very nature of information itself. The demon wasn't some monster trying to break the rules. It was more like a guide showing us that the rules were deeper and more interesting than we ever thought. And it leaves you wondering, right? What other fundamental laws of nature are secretly all about information?